another quick stream today. I streamed on Tuesday around 8:30, and turns out that about for half of my stream, my microphone was muted. So seems to be working this time. I'm hoping. I got through like 5 exercise C++ track on Exercism. So that was pretty cool. Although Copilot wrote most of it for me. Copilot seems to be doing pretty well at C++. So we're going to continue on. So this one we're doing is interest is interesting. So here's the workflow that I've got going on. Head over. Oh, hold on a second. There's a way that I could like pin the. Oh, did I have to? How did I do this again? There's a way to pin. Was it Alt Control? Oh, that's what it was. So you press Control or Command Tab, and then you right click on this and say, show this window on all desktops. Very cool. Okay. So now I should be able to see the chat regardless of which desktop I'm on. Okay, great. So what I do is I copy that thing over, close out on I did this exercise I think a couple days ago. And then I just do paste that into here, make this a little wider. Cool. Then we CD into interest is interesting. We do, I should make a script for this, but right now I'm just going to do it. So we do make directory build, we CD into build, and then we do cmake g unix make files dot dot. And then while that's doing its thing, usually I open up the files. Interest is interesting. The test itself, because the way they want us to do this is to like essentially do one test at a time. So they actually comment out all but one test and basically just keep doing it one at a time. But for these easier ones, I've been just going through and uncommenting out all the tests and doing it in one go. So let's do that while this is still building or generating the make file. Okay, go down here. This is a lot of tests. Okay, so, and while that's happening, let's take a look at what we need to do for task. It's saying, okay, so this is to practice loops. General syntax, there's a for loop, init statement, condition expression, while loop. Okay, interlude increments and decrements. Okay, you can go before or after the variable. For loops an example, int I 1, I is less than 10, plus plus I, including 9. Okay. Interesting. This syntax is kind of interesting. Not familiar with that. So I'm going to run make. I'm expecting everything to fail, but it takes a while to build and seems to run better after I've run it once. So take a look at the instructions here. So in this exercise, I'll be working with savings accounts. Each year, the balance of your savings account is updated based on interest rate. Interest rate in your bank account gives you depends on the amount of money in your account. Its balance 3.2134 balance less than $0. Balance gets more negative. Got it. 0.5 for a balance greater than or equal to $0 and less than $1,000. 1.621 for a balance greater than or equal to $1,000 and less than $5,000. 2.475 for a balance greater than or equal to $5,000. We have 4 tasks, each of which will deal with the balance and its interest rate. So first of all, calculate the interest rate. Implement the interest rate function to calculate the interest rate based on the specified balance. Got it. So basically, just depending on which range that is, give the appropriate interest rate. Is it supposed to be in? Yeah, just as they have it as a decimal there, or as in percents. So Copilot is doing an excellent job at knowing what to do with most of these. So often I just pause long enough for it to like think, and it just kind of gives me the whole thing. This time it's not, so we'll just say if balance less than 0, return 3.235. Okay, there we go. It's starting to catch up here. Else if balance is less than 1,000, return 0. There we go, there's the rest of it. So 0.5, 1.621, 2.5, 2.475. Is that correct? That looks fine. Very cool. Okay, so first task done. Next task. Calculate the interest. Implement the yearly interest function to calculate the interest based on the specified balance. Yearly interest. So this is annual. Did they talk about accrual rate? Each year the balance of your savings account is updated based on the interest rate. The interest rate. Okay. So I think it's as simple as saying for 1 year, implement the yearly interest to calculate the interest based on the specified balance. So just the amount of interest that's accumulated. Okay. I think I actually want this. I'm curious if that's supposed to be negative or positive. I'm not really sure. I would like it to be negative. However, I don't know. So if we make that negative, I think it would make our lives easier later on. However, they probably have tests just for that function, and it may not pass those tests. Okay. So I think we just want to return, that looks right, balance times interest rate of the balance divided by 100. Yeah. And that should get it, because this is negative, should give a negative amount as well. I suppose we could see how many tests are passing now. I think this will run a little faster now. And let's read the next task while that's running. Calculate the interest. Implement the yearly interest function to calculate the interest based on the specified balance. Oh, that was number 2. Okay. Calculate the annual balance update. Implement annual balance update function to calculate the annual balance update, taking into account the interest rate. Okay, so more of them pass this time. That's good. So basically, after 1 year, it's basically just adding the balance plus the interest for that, right? So return balance plus the yearly interest. There we go. Okay, and then this is finally where we need the loop, right? Calculate the years before reaching the desired balance. So this means that the balance after 1 year is start balance plus interest for the start balance. The balance after the second year is the balance after 1 year plus interest for the balance after 1 year. And so on until the current year's balance is greater than or equal to the target balance. Okay, so it needs to be an integer. Okay, so we're going to use a while loop here. We're going to start off by declaring an int years, started at 0, and we'll say, yeah, that looks good. While balance is less than target balance, balance is equal to annual balance update years plus plus, and then we'll return years. That looks fine. Let's see how many tests pass this time. Seven failed. Okay. Okay, so as I expected, this one should not be negative. So that means that we need to check to see if the balance is... Oh, okay. Well, the balance itself is, if it's less than 0, and then you multiply by the interest rate, is already going to be negative. So I shouldn't have put a negative in front of that. Okay. Hey, all passed. Okay. So we do exercism, submit. Cool. Head back over here and refresh the page and submit that one. Alrighty. I've been going through like the syllabus and trying to cover all the stuff here. We'll head over to arrays and vectors. We'll just do one more and then call it a night because I don't want to spend too much time tonight on this. Okay, so same thing. Head over here, close out of these tabs, download the exercise. And then CD into making the grade. Okay, and we do make dir build, CD build, and then C make G Unix. There we go. Okay, and while that's happening, we open up making the grade and making the grade. I wonder if there's a way for me to open up more than one file here. README for making the grade. README. There we go. Okay, so what do we need to do here? We got arrays and vectors. We need to include them. We need to define the type of them because they're generics. Not only type, but also length. Vectors usually need more space as they allocate memory for further growth. You do not need to specify a size. Cool. So if we don't know how long it's going to be, use a vector. If we do, use an array. Element access vectors and arrays share the same functions. To access their elements, you can use the member functions front and back to get the first and last elements of the container. There's also at and the square brackets operator to access specific elements. Very cool. Vector modifiers. As a vector is not fixed in size, it's possible to add or remove elements. The two common functions for that purpose are mplaceBack and popback. Interesting. You can check the containers for emptiness with the member function empty. If you want to know the number of elements, you can use a size. Alright, while you can give partial credit on exam questions, overall exam scores have to be ints. So before you can do anything else with class scores, you need to go through the grades and turn any double scores into ints. Overall exam scores have to be ints. So before you can do anything else with the class scores, you need to go through the grades and turn any double scores into ints. Okay. Create the function round down scores. It takes a vector of student scores. The school's requested rounding is a truncation. Lucky for you, C++ can cast one type to another with static cast. The static cast conversion from double to int cuts off any digit after the decimal. This function should take the input vector and return a new vector with all the scores converted to ints. Okay, easy enough. Return. Actually, I probably need to do an actual loop because they don't have like a map or something. So we're just going to need to say, well, I guess this is C++. We want to be efficient, right? Is this thing being passed in by reference or by value? No idea. also, we have the size, so that's how we can know how many there are in there. Is there anything about iterating over it? Nope. So I guess we just use a for loop. Okay. So I think we want to do for. Ooh, that's cool. I don't know what that does. Auto score. Auto, I think, says infer the type. Student scores. Score equals static cast int score. Interesting. I don't know if that works or not. I think what we need to do, that's not how I would have done it, so let me do it the way I would do it. For, how do we define a variable again? It would be int we'll say student. I think we initialize it into 0. Student less than student scores dot size student plus plus. There we go. We want to set student score student equal to static cast int of student score student. Yeah. That's how I would do that probably. Alright. Non-passing students. If you were grading the exam, you noticed some students weren't performing as well as you'd hope, but you were distracted. Oh, sorry. At the end of this, I think I need to actually return student scores. There we go. You distracted and forgot to note exactly how many students. Create the function count failed students that takes a vector of student scores. This function can count up the number of students that don't have passing scores and return that count as an integer. Student needs to score greater than 40 to achieve a passing grade on the exam. Okay. It's not happy with this. Standard vector double, allocator double to standard vector int. Okay. So instead of doing this in place, let's just say standard vector int which should be, oh, it's a vector anyway. Okay. So we shouldn't need to define its size. Rounded scores. Okay. So what we're going to say is rounded scores student, and then we'll return rounded scores. Okay. There's probably a way of doing that in place and then casting it, but this works, I think. Okay, now we want to count failed students. So we'll do the same thing again. Let's say failed student starts at 0, and then for in student 0 to student score size, student plus plus. If student scores is less than 40, then it is 40, right? The student needs a score of greater than 40 to achieve a passing grade on the exam. So a fail is less than or equal to 40. And then we'll just return back failed students. Cool. And do we have any red lines here? Okay, now it's happy. Cool. The best. The teacher you're assisting wants to find the group of students who perform the best in this again. What qualifies as best fluctuates. So you need to find the student scores that are greater than or equal to the current threshold. Create the function above threshold, taking student scores into vector grids, and threshold and int the top score threshold as parameters. This function should return a vector of all scores that are greater than or equal to threshold. Okay. Easy enough. int best students, and then for int student 0 student in less than student. There we go. Now it's helping us out. Greater than equal to threshold best students. Good. Return best students. Cool. Oh, we actually want the students themselves. Okay. So in that case, this will be standard vector best students, and here we're going to say best students dot, what was it that we need to use? They have pop back and place back. It's really strange. And place back student scores student. Okay. It's not like in this over here. Oh, it's because I didn't actually define the type there. Int. There we go. Should be happy now. Alright, now create a list of, what was it? Calculating letter grades. Teacher or your assistant likes to assign letter grades as well as numeric scores. Since students rarely score 100 in an exam, the letter grade lower thresholds are calculated based on the highest score achieved and increment evenly between the high score and the failing threshold of less than or equal to 40. Create the function letter grades that takes the highest score on the exam as a parameter and returns an array, not a vector, of lower score thresholds for each American style grade interval. Ooh, interesting. So where the highest score is 100 and failing is 40, we essentially need to do A, B, C, D, F. So we take 100 minus 40, which gives you 60, and then we divide that by 4 for increments, right? If the highest grade is an 88 minus 40, that leaves us with 44, divide that by 4, and you get 11. Okay. Alright, let's see. This one's a little bit more complicated. So first we need to find the maximum. Oh, never mind. I must have skipped this section. Or, okay. They're suggesting that you have a letter. Oh no, never mind. Create a list of grade thresholds based on the provided highest grade. Create a list of grade thresholds. Oh, okay, this is just creating the thresholds. I see. Okay. What do we need to return again? Just the threshold things. Okay. Alright, so we're going to say nope, that's not right. We're going to say interval size. Sure, interval size is high score minus 40 divided by 4. Okay. Standard array int for grade thresholds. For int grade less than grade thresholds dot size, grade plus plus, grade thresholds grade is equal to 41 plus interval size times grade. Yep. And then we return back grade thresholds. That looks fine to me. I don't know if there's going to be one that's not cleanly divisible by 40, but we'll find out when we run the tests. Matching names to scores. You have an exam scores in descending order, and the respective student names sorted in order of their exam scores. You would like to match each student's name with their exam score and print out an overall class ranking. Create the function student ranking with parameters student scores and student names. Match each student name on the student names vector with their score from the student score vector. You can assume each argument vector is sorted from highest scorer to lowest scorer. Function should return a vector or string to the format rank student name student scores. Rank dot student name colon student scores. Okay. Alright, so we're given the student scores and the student names. And we're supposed to just rank them. So standard vector, standard string, rank students for int. Wait, hold on a second. Do we even need, oh no, we do, okay, we need this, we only need the scores for the fact that we put them together. We don't have to worry about sorting them. Okay. So we want to do ranked students and place back student names, but we probably want to do a printf. Is that right? Not printf. No, I don't actually want to print it, but we want to be able to. Oh, okay. We can just kind of add them together, right? Yeah. Okay. So we should be able to just do student. Let me think about this. Let's start this at 1. Let's do this minus 1. Or rather, less than or equal to. Let's do student dot toString. There we go. Copilot helped us out this time. The dot with the student name, I think we want a colon, and then the student score, which is also an int. So that also needs to be converted to dot toString. Expression must have type class, has class type but has type int. So maybe there's a there's just a toString. I don't know. Let's see. Int toString. Is that a thing? Nope. How about just toString? Plenty of overloads on it. Okay. So toString is probably overloaded to take an integer and return a string. And same thing here. toString there we go. We get rid of all the red lines. Yep, we're happy now. Alright, what's the last thing? Perfect score. Although a perfect score of 100 is rare on an exam, it is interesting to know if at least one student has achieved it. Create a function perfect score requires student scores and student names. The lists are the same as in task 5. The function should return the first name as a string of the student who scores 100 in the exam. If no 100 scores are found, an empty string should be returned. Okay. For int students 0, student lesson size, student plus plus. If student score student is equal to 100, return student name 0. Otherwise, return an empty string. Okay, I think that's everything. Oh, I forgot to run make. I should have done that a long time ago. Well, okay, we already found an issue. ToString was not declared in scope. Did you mean standard ToString? Okay, so let's figure out how to make an int to a string. C++ int to string. Standard to string I. No more reds. No more reds. Okay. Not sure if I needed a to import a library for that. Standard string. Yeah, that's fine. All right. Hopefully these all work. I did it all in one go. Oh, you know what? I don't think I ever uncommented this out, so it's only going to try the first. I'm curious if there's going to be a test about that threshold thing. Test threshold. Yeah, so some of these are not divisible by 4. Let's see. We'll see what happens. Hey, they all passed. Okay. Oh, okay. They didn't all pass. That was just that first test passing. Let's try that again. Segmentation violation signal. That's not good. Check correct mark conversion, all less than 5, 0.5. Wow, okay. So, clearly did something bad here. I got a seg fault. Maybe we'll actually do this test by test now. So let's move this down to this guy. I think it was already having a seg fault at this point. Okay, so what could be causing it? Yeah, it's already having a fault. Round down scores. Standard vector int rounded scores. Maybe it's because I never declared how large this vector needs to be. Didn't think I had to. Maybe we'll use in place back instead. In place back is the right one, right? Let's take a look at this. In place back. Element access. Construction. Yeah, I mean, that looks fine. Construction vector countdown int. Did I ever include the vector? I don't know. Yeah, they're already up there. Okay. So what's going on? The first test passed, which is just an empty, empty input here. Okay. Zero less than size. Should be fine. Student scores size. Student plus plus. Round scores student. I don't know if I can do like a printf. I think it's like D or something. D, student scores student. Yeah, why not do that? Okay. Let's see what that does. Is that coming from? From here? From the test? Yeah, it is, okay. But then it already has an issue, I think, probably just putting it into there. Because the vector is not prepared for it, I suppose. Is that a thing? Copilot seems to think it is. Sure is. Okay. Alright, so it looks like if I'm going to place things into the vector, I need to explicitly say how large the vector is going to be. So I do that in a couple places. Here I'm using in place back, so that's fine. Here I'm using an array. Here I'm using a vector, also doing in place back. Okay, so that might be the only place there. Let's move this below all of the task 1 tests. Oh, there's only one more. Let's do test 2 as well. Why not? Let's see if we finish task 1 and 2 correctly. Wait for that to catch up. Should be fine. Okay, task 1 and 2 is done. Let's do 3 and 4. Why not that? 3 and 4. Or just do the whole thing. Yeah, I'll just do the whole thing, and then I'll see which ones fail if they do fail. One failed. Only one. Segmentation violation signal. Which one? Oh, well, it probably... Okay, no. Test case is 13. Does it tell me which one failed? Rank 1 student. So this one failed right here. Which task? Sorry, I missed that. Task 5. Student ranking. So here's the saying there's only one student names. We have a standard vector of strings, rank students. Student 1. Student is less than or equal to student scores dot size, which is 1. There's only one. Student plus plus. And place back toString student, which is number 1. Aha, okay. Student minus 1. I'm surprised it worked for any of them. How did the other ones pass? Okay. Oh, I guess it didn't pass. It stopped there and then didn't continue. Alright, so that's all the tests. All the tests are passing. Very cool. So, I think I'm going to basically call it a night here. Submit that. Take a look at where we are. I'm really confused because I'm supposedly... You only needed to complete like 5 exercises to get the badge. And I've completed, at this point, let's see how far we are on this. I've come down to most of the, it looks like, okay, we gotta finish up a couple more things before we get to references there. Okay. Yeah, so go over to my profile here, and badges. For some reason I still haven't gotten the badge for, I guess it would be Jurassic July. However, I've already completed, what is it? I guess the 12 and 23. I gotta go to like the main page and then go to explore 12 and 23 and then see, yeah, we gotta finish 8 exercises for C++. So maybe I need to do one of these actual exercises. I don't know. Alright, well, I got a lot further in this month. Earlier on, most of the time I was scrambling in the last week to get a few exercises done. So yeah, hopefully I'll get a lot more of the way through the C++ track. How far am I now? I'm 12.5% already, so it's pretty good. Alright, thanks. See you all.